All right, so let's start off this chapter on volume by actually looking at something from last year. Our job today is to look at volume of cylinders, but we're actually going to start off with prisms from last year. So last year, you did some more on volumes, but you did other shapes, and specifically one which is called a prism. This idea of a shape that has a particular base, and then that base just goes upwards to create the shape, and the top and the bottom end up being the same. And you were given this formula. And you may not have learned it this way, but the way I like to think of it is I always think of a prism is just like an office building. An office building has a first floor, and then all the other floors are just stacked on top of it, usually the same shape. And that way, first floor, second floor, third floor, and so forth. And so that's where this volume formula comes from, is that this capital B stands for base. This first floor is the area of the base. And now if we think about adding more floors to it, so if I add on got to grab it here first, a second floor, and then a third floor, and a fourth floor, and a fifth floor, and so on, that I'm just making multiple copies of that same floor. And so that's why we multiply by the height. It's just B is the first floor multiplied by the height of the overall building, which gives us the entire volume of everything. Now, why do we need to know this? Well, because it relates to cylinders. So if you ask yourself, if you take any prism and then right next to it a cylinder, you ask yourself, well, how are these similar in characteristics? What about them is the same? Because obviously there's a lot of things that are different here. Here, this has a hexagonal shape, this has a circular shape, but there are some things that are the same about them. Now, if you take the time to think about it, the big idea is this, is that each one maintains a consistent shape as it goes up from the base up to the top. And again, it's that same office building analogy. So if I take a look at my first hexagonal office building here, here's the first floor. And then as I raise that first floor up, it's the exact same on top, that it's consistently the same shape from bottom to top. Well, a cylinder has that same characteristic, and the only difference is the first floor is a circle instead of, in this case, a hexagon. But it consistently maintains that circular shape all the way up to the top. Now that's important because what that means for us is that we don't need a new formula, that we can use the same formula for prisms from last year on cylinders this year, which is volume is just capital B base, that first floor, times the height. Okay, so last year you might have done a problem like this. You would have taken this green base down here, you would have multiplied it by the height of the prism, which in this case it's on its side, it's like a building that's fallen over, and that would give you the volume. Well, for us this year, it's the same thing. You find the area of the first floor, the base, you multiply it times the height of the building, and that also will give you the volume. So whether it's prisms or cylinders, same formula. Volume equals capital B base times height.